Let's talk about feedback and LFO depth. So we know that with a regular delay, turning up the feedback will increase the amount of delays. So let's try that out. Of course, we have no feedback, so we're getting a single delay. And if we turn this up, we're hearing more and more delays with the more and more feedback we get. And now we know that if we were to change the delay time, or in other words, if we were to manipulate this manual control, we would effectively change the pitch of what's going into it, or I guess what's coming out of it. Because by turning it up, I'm increasing I'm decreasing the distance between the peaks. By turning it down, I'm increasing the distance between the peaks. And then what the LFO is doing is simply modulating this parameter, so I don't have to do it by hand. So let's turn LFO depth all the way up for the first delay unit. And for the second delay unit as well. Now you can hear, by turning it up for the second delay unit, all that it seemed to do was increase the amount of depth, or the amount of pitch shifting going on, which is exactly what it's doing. So our LFOs right now are locked. That is, they have the same pitch. By setting the frequency of LFO 1, we are also setting the frequency of LFO 2. We also have the option to offset the phase of LFO 2 from LFO 1. Now, LFO 2 is what's automating the delay time for the second chorus unit, and LFO 1 is automating the delay time for the first chorus unit. Now, if we look at our diagram, we know that the signal going in will be modulated, the pitch will be modulated by one LFO, and then that same signal's pitch will be modulated by the second LFO. So what happens if we offset the LFOs 180 degrees out of phase? It basically cancels out the modulation. And if we want to see kind of what that looks like, I have an instance of mod 7 set up here. And I the the oscillators as all carriers. And oscillator 1 and 2 are simply sine waves. And they are being summed. And let's look at what happens when we phase shift one of those sine waves. I have to continuously re-trigger the note in order for you to be able to see this. But pay attention to the oscilloscope here as I'm changing the phase parameter. Whoops, hold on. Let's not go through our effect. There we are. Now pay attention to this waveform. It goes down in volume, and then up in volume when they are locked in phase again. So that summing effect, that cancellation effect from summing to out of phase sine waves is what we're doing with the LFOs that are modulating the delay lines in the bichorus effect. So let's turn that off. Let's turn back on our regular noise burst. And let's go back to our effect, turn that on. So right now with them 180 degrees in phase, we already heard that it modulated the delay, that it changed the pitch of the input a lot. But if they're 180 degrees out of phase, we get a much more stable sound. We've essentially turned down the depth of modulation by summing the LFOs together. In other words, we've effectively canceled out the pitch shifting that happened in the first chorus unit with the second chorus unit, which is kind of cool. It's not a perfect cancellation. You can still hear some modulation going on, but it's certainly a lot less than if the LFOs are in phase with each other. Next we'll explore dual mode.